Oh my golly, hello. Hello, welcome again. Part 31, I think. Amazingly, still going. Drop frames 0. Looking good. Okay, so this is me working on a WebAssembly interpreter in Ruby. If you haven't seen this before, this is why I'm doing this. I'm doing it to have fun and to demystify WebAssembly for myself, maybe for you if you're interested. You don't have to be. Probably helps if you're a bit interested. And just share how I do it, let you kind of look over my shoulder as I work on a large and potentially tedious project. My priorities are thus. It's more important that I have fun than that I complete a fully functional WebAssembly interpreter. I want my code to be correct, even if it's not fast. I want my code to be clear, even if it's not clever. I'm trying to do it all in pure Ruby with no native extensions or anything. So far, so good. I'm trying to do it with no third-party dependencies, which is also working so far, so good. So yeah, that's it. I will briefly have a little retrospective about what happened last time. Don't really remember what happened last time. It wasn't very good though. 3 things, I suppose. I did have to make some changes to the parser again to make progress on the tests. I mean, you know, mainly the feeling I got from this is that it would just be really nice at some point to have bottomed out the work on the parsing and be able to just focus purely on the interpreter, but I'm definitely not there yet, you know. As I'm adding in new features and new instructions, it does necessitate going back to the parser and adding more stuff. I mean, if it was just adding instructions, at some point, I think I'm just going to be adding instructions, basically. And I think that'll be all right. You know, the problem is that there's other stuff that I haven't implemented yet beyond just the long tail of instructions. You know, it's stuff like tables, you know, stuff like module fields, you know, top level module fields that I haven't implemented yet that contribute to the initial identifier context and name resolution and all that kind of stuff, and type definitions potentially. So yeah, I just still keep having to revisit it even though I don't really want to. You know, I suppose that's just how it is. It's not really what I want to be doing, but it must be done in order to be able to get to be able to get stuff through to the interpreter. So I'm just kind of semi-reluctantly cracking on with that for now. And that's without even thinking about the actual kind of refactoring I want to do on the parser. So things like changing it to work in a single parse, which I may or may not choose to do depending on how sick I am of looking at the parser by the end of this. But it's always been my intention to go back. You know, at the moment I've got a hack in the parser that just duplicates the entire S expression and parses it twice. It'd be better if I wasn't doing that. So yeah, I'm starting to feel there's a bit of a build-up of debt in the parser, but I just don't have any appetite for dealing with it at the moment because there's so much stuff that I have to do in the parser. I don't really have any appetite for anything that's currently optional, but maybe that'll change in the future. Anyway, last time I left off with, I think it was lm.wast was the file I was working on. I got it to the point where that was parsing successfully, but not executing successfully. So I think I'm going to pick up, at least initially, I can pick that up, and I hope I don't have to do any work on the parser to begin with, but we'll see. I mean, I probably will, won't I? Oh well, we'll see. Yeah, so the tests failed on GitHub for the first time when I pushed them up at the end of the previous stream. And that's because there had been changes to the WebAssembly tests that changed sort of in the upstream repository, but I haven't. In fact, until last time, I don't think I had pulled in my clone of those tests since I began this project back in September. So they were many months out of date. And so it's not surprising that eventually they introduce some new tests that that cause my my build to break. So I mean, if nothing else, it's good to know that the system works. This is part of the reason for having those tests running on GitHub, was to be sort of continuously integrating against the upstream version of those tests rather than allowing my implementation to kind of drift out of sync with them. I'm not really sure what to do about that in future. I mean, maybe when I remember, I might update the local tests more frequently. Like, as you know, I always run the test one final time before I push them up. And so maybe this time I will try to remember to also fetch the latest WebAssembly test to just check. Or maybe I could do that at the start, actually. Maybe I can start by updating them to give myself some confidence that whatever I'm developing against is actually up to date. So yeah, maybe I'll do that this time and see how that goes. There we go. Actually got an action out of this retro. That's never happened before. And finally, he says, checking OBS. So last time the stream didn't really work properly. There were a lot of dropped frames. I think the audio was okay, but the video was pretty terrible. So I did make some changes to my network setup in the hope it will help. I mean, it may well have just been a problem on YouTube's end. I don't know. But anyway, I spruced up the configuration of my local network. At the moment, it seems absolutely fine. But the only way to really know if that's done anything is to try it for real, which I am doing right now. So let's see if things actually work this time. So, all right. So normally this is the point where I'd run the test, but how about I do this instead? And let's just see what changed there. I should have fetched so that I could have, so that this would have been more straightforward. Ooh, yeah, this has reminded me. I forgot to say. Those two pull requests that the editor of the WebAssembly specification made based on my confused questions have been merged. So it's good that I did this fetch because that has reminded me. Closed. Yeah, these two. So as you can see, these have both been merged now. So the label shadowing change, which is this. This is what reminded me. Yeah, this sort of additional clause to allow labels to be shadowed, and a little bit of prose that explains that has been merged. And then this thing about allowing the initial identifier context to reach function bodies has also been merged. So that's good. In fact, it looks like those are the only changes since last time. Yes. So that's good. So hopefully that means that when I do run the tests, nothing is going to be broken. Let's have a quick look at what I did last time. Oh yeah, this was the change I had to frantically make to fix. This was like after I thought I was done and I pushed it up to GitHub and the test broke. So that's not really what I was doing last time. Support parsing the register command. Yeah, I think this was the last piece of parser support I needed. Let me just... Yeah, okay, pending test failed successfully. So I'm just gonna... yeah, let's do that. So I think... Yes. So without that change, there was it was trying to parse register in lm.wast. And with that change, oh, this is just another parser problem. Either I'm misremembering where I got to, or I'm just confused. Let's just see. Yeah, I mean, maybe I'm just being too optimistic there. So what was when I ran these tests? Yeah, okay. Well, somehow I had persuaded myself that there was no more parsing work to do for this. But that's clearly not true. Like, it's still failing in the parser. So time for more parsing fun, I think. Where by fun I mean not fun. Hopefully we're close to the end of what's needed here, though. So this is complaining parse table. Let's see what's going on here. LM. Okay, so table T10 func ref extern ref. Oh, those are inside a certain valid. We don't care about those. This is it. Table $T export table to externref. Okay. Well, I feel like at some point I'm going to have to get a proper grip on what this means. I mean, I have a very vague sense of what it means. In that I think... Well, no, I don't. There's some notion of like an extern... No, I don't know what it is. Obviously, it's some kind of pointer to something in some kind of store, but I just don't know whether it's supposed to be more specific than that, or if the idea of this is that this is just sort of an opaque reference to something that's provided by the host environment that's not part of the WebAssembly program. I just don't really know. Maybe I should. It's sort of embarrassing that I don't even vaguely know what it is. So I'm just going to look in tables here. I mean, if nothing else, I need to understand this syntax. So this is table, export table to externref. Okay, so tables can have inline imports and exports. So we're going to, if we don't already deal with this, we're going to have to deal with it. So there's the inline export. There doesn't appear to be any support for the inline import. We don't need that here, fortunately. Just thinking, it reads table, it reads an optional name for the table, exports, and then parse table type. Oh, so this is the thing I think that can repeatedly, that reads either just the minimum or the minimum and the maximum size of the table. I think that's what the table type here is. Table type, yeah, limits. So this is either a minimum size or a minimum and a maximum. I could definitely be more specific about that here, and I'm also just throwing them away at the moment. I'm assuming that there's a table test that's going to exercise this a little bit more exhaustively, and I further assume, yeah, that is not currently running. So maybe that's maybe that's something to sort of add to the load as I am to make this longer. Maybe this is one to look at maybe after this. But yeah, you can see here it just reads funcref. So I mean the straightforward fix here is just to allow it to also read externref. But the reason I came here was to try and get my brain to understand what these reference types mean. Funcref or externref. Okay, that's actually, I'm sure I've read this before. Let's try and read it again. Reference types classify first class references to objects in the runtime store, right? So that's sort of what I thought. Funcref is references to functions. So I guess that's, you know, we can think about this as essentially a pointer. Is that the right way to think about it? Like we can store, I'm not sure what the right like mental model here is in terms of lower level programming language, but like, yeah, I guess we could think about this as like a pointer to a function, but the function doesn't actually live in the store. Or maybe it does. I suppose it does. Yeah, I suppose all the functions sort of get instantiated and turned into runtime function objects. So yeah, it's essentially a pointer to the instance of a function, whatever that means. Just an executable function. So what's externref? Externref denotes the infinite unit of all references to objects owned by the embedder. That's sort of what I was alluding to earlier. So it's like the embedder being, I think, the sort of the host environment that this WebAssembly runtime is inside of. Yeah, a WebAssembly implementation will be embedded in a host environment. This environment defines how loading of modules is initiated, how imports are provided, and how exports can be accessed. The details of any particular embedding are beyond the scope of the specification. So, you know, we can make all those decisions. Objects owned by the embedder and that can be passed into WebAssembly under this type. So that all makes sense to me, but I suppose the thing that I'm having trouble with is that I don't understand what the interpretation of this type is. Like, functions can be called, but what can you do with an externref? Like, what's the semantics of an extern? Like, is it just completely opaque? Is the idea that, like, you know, I can't operate on it, but I can return it? I'm not quite sure how to think about it. Not very much here. This is just in syntax. Well, I suppose I'm just going to be resigned to not understanding it for the moment. Anyway, let's see if this change... Okay, right. So that's fixed that problem in as much as the parsers are not complaining about that anymore. I mean, I assume that this is... well, all of this information is important, right? Like at the moment, we're just ignoring all of this. Like parse table type is just skipping over it, and we're not storing it in the AST at all. To me, that seems unlikely to be a sustainable strategy in the long term, but let's say something like support externref in table type. I'm sorry, Etienne. I'm just doing this again. So Etienne suggested that he made a further suggestion, friendly suggestion / complaint, that I could just get in the habit of putting edit on the end here. because I was complaining before about needing to decide up front, like when I'm typing the alias here, whether I want there to be edit, and he was like, well, you can just put it on the end. So maybe I'll try and remember to give that a go, but it's too late for this on this occasion. I mean, really, I don't know how motivated I am to change my behavior, to be honest. I'm just trying to be accommodating, but I'm pretty stuck in my ways as well, so it's not very often I adopt a new habit. Although I did teach myself to type git switch and git restore instead of git checkout, so I think the moral of that story is that anything is possible. Support externref in table type. I don't really understand what externref means. Is it a completely opaque reference to some object originating from the host environment, or are there some operations we're able to perform on it? Let's say what an externref is or means. Yeah, it was better before. I don't really understand what externref means. Is it a completely opaque reference, some object originating from the host environment, or that some operations we're able to perform on it? Anyway, it doesn't matter for now. We just have to be able to parse it. In lm.wast. Okay. All right. Oh, let's make a third tab. Okay. Puts parsing. Well, let's just do this. Okay, so I mean, it's just going to be the first appearance of table.get in here, isn't it? So okay, so it's actually right after this. All right, so I mean, I obviously haven't read about what these instructions do, but I can kind of guess what they do. So this at least partly, well, I mean, this doesn't really answer my question, at least not in the positive, but you know, this is showing, until this moment, I didn't realize that tables were mutable. I think I'd assumed that they were just sort of static structures, but they're clearly not, because you can set them apparently. So we've got table.get and table.set, which again is making me feel a little bit like, well, maybe we should have got table working before trying to get lm working, but I think it might be a little bit chicken and egg, because I assume that tables, oh no, actually look, table is really short, although it looks like this is only a test of syntax. At least it is for me, because I haven't implemented assert invalid or assert malformed yet. So yeah, okay, that wouldn't have helped. But yeah, it looks like we can, these externrefs, if we've got a table, I guess, of capacity 2, that contains externrefs, we can read and write them. So it is possible to, if the host environment has supplied some externref, then it looks like we are able to store it into the table, and then get it back later. So the fact that these tables are mutable means that now it's easier for me to imagine these things, you know, the host environment, you know, on the Ruby side, I've got some Ruby objects that I've manufactured, and I want to pass them into the WebAssembly code and have it store them in a table at different offsets. And then at some point, you know, they could be, you know, let's say they're Ruby symbols, for example. and I want them all stored in a table, and then when I call into the WebAssembly code and it wants to return a meaningful value back to me, it could maybe retrieve one of those symbols from the table and then give it back to me. So even though it's not able to operate on those symbols or Ruby strings or instances of some user-defined class, it is able to squirrel them away in a table and then return them to me later. So I mean, I'm just thinking out loud about like what my mental model of these things might be. I'm not sure if that's germane really, but anyway, so we need to be able to mutate the tables. What is my actual, just out of interest, how am I representing tables right now? Oh, right, I'm just copying the abstract syntax tree. And it looks like a table.elements is just an array. Okay. All right, anyway. The immediate problem, I'm sort of, sorry, my brain's going down a bit of a rabbit hole there. The immediate problem is that we can't parse table.get. And I assume we also can't parse table.set. Both of these both table.get and table.set just take an index. Let's see. Table instructions. Yeah. So in terms of arity, I think it belongs, like static arity, I think it belongs here because this is where all of the instructions that take an index live. So all of these take some index. We pick out the correct index based on which instruction it is, and then we parse that index using the appropriate index space, and then we generate the appropriate, we call the appropriate AST node constructor down here. So I think I'm just going to stick it in here. So this should be table.get, I think it was. Yes. Table.get. And here we're going to have to say context.tables. I'm not sure that that exists. It might, but it also might not. And then down here, this is just going to be table.get. Table.get. So we're going to need a table.get AST node. And it's expecting an index, because when we call the constructor, we provide an index. So yes, that's correct. I don't even know whether context.tables is a thing, but rather than try and find out, let's just run it. Apparently it is a thing. Even more surprisingly, it appears to have been able to look this up. So hold on, have I already done all of the machinery for this? So in build initial context, table, yeah, wow, surprising. Turns out I am populating the initial context with all of the table identifiers, so this will have put an entry in the initial identifier context for this $t, and then this will resolve to table index 0. I am as surprised as anyone about that. Let's just say I'm just trying to decide what the commit message should be. I suppose it's all this, isn't it? Support parsing the table.get instruction. And I honestly don't think I have any more to say about that. And I think it's the change for table.set, I think, is going to be essentially the same. That's the next change. So this is going to be table.set. Table.set. And this is going to have to be table.set. And in here, we're going to have to do table set. Ah. Okay, so, well, that worked as far as it goes. So this is just table.set. But now we've got a problem in parse table type again. Let's up here, let's just do this again. See what's going wrong here. I'm confused about... I'm confused. Let's just see this. So it's parsing table type to externref, and then it's saying parsing table type again. I assume we're down here. So hold on, who's the parse import? So this is happening during parse text fields. Where do we... So is there an import here? Yeah, I assume it's coming from here. Parsing import, import exporter table, table $t to externref. So there's a mistake here where this is the table type to externref. The $T is part of the import syntax, I think. Let's just double check that. Yeah, I think it must be. You're just giving it a local, giving it a local ID within the module. But I don't think I've needed to support that yet. So this might be the first occurrence of that. Oh no, hold on, look. There's one there. I mean, whichever one we do, there's always... Oh yeah, but we got to do the read, yeah. So maybe... Just trying to think of a noun for these. You know, if I could do this into a local variable like this, then I could move peek out, and I think that's what I'm going to do. I think this is just a single refactoring, right? Is to make it so that we always read into some local. So it's going to be func table, memory, or global. Can I do that? Just to, I don't know, just to make it clear what's going on. Then we optionally read an ID, and then we've got this case that calls the right type parser depending on the kind of import. Let's just see if that's broken anything. Oh, well, it successfully parsed everything. I'm just going to run the tests, because I think that's the right shape of that parse import. It's just to unconditionally try to read the optional identifier, because there's always going to be one. There's always going to be the possibility of one, is what I mean. Like, an obvious thing that I'm not doing here yet, and I might have a to-do item for this. I don't know if I do. Oh yeah, no, here it is. Look, per the spec, make sure that import, I mean, I'm talking specifically about func here, but import with identifier adds that identifier to the function's index space of the identifier context, so that function identifiers get converted to index correctly, ditto for globals, memories, tables. So I think, yeah, so that change hasn't broken anything new. In fact, it's made it so that lm.wast can now successfully parse. But now there's a complaint here that, oh, it's looking in functions, but somehow the index here is nil. So, well, we'll investigate that in a sec. So maybe I can... Maybe I'll split this up. You know, just insert this at the beginning. So that it looks like this. And then I think the change, which I think you can't see the change there. Sorry, that was pointless faffing about with Git. I think it just makes it easier to see what's changed. So here I can just say read import type into a local variable. And I can say when parsing imports, and I can say I'm doing this so that I can extract the reading of the optional index well, let's say consolidate. We need to do it regardless of the kind of import. So it's silly to reproduce it in each branch of the case. So now, just say, I'll just use the same language as whatever I just did there. Consolidate reading of optional index when parsing imports. I think that's fine. Okay, so let's try to understand what's going wrong in the interpreter here. How many actual assertions do we have here? So the only one I support really is assert return. So this, yeah, it's this very first one, invoke call 7. It's going wrong. So let's just, we need to be in the interpreter. In fact, I think evaluate instruction is the more relevant part. So we're invoking call 7. That says call indirect. There's a type here that we're presumably ignoring. 7. So I think that should be calling const i32a, and it should return 65. Yes. So how far are we getting? We're evaluating 7 correctly. Well, I assume. And then call indirect. table index equals 0. That's right. Type index equals 0. That is also right. Oh yeah, okay. So we do need to know the type index because that tells us the type of the function, which we're going to need to know for the calling convention of the function. Like if we return from the block, we need to know what the arity of the, if we return from the function, we need to know what the arity of the sort of the top level block in the function is, and that's what this tells us. So that appears to be correct, but what's going wrong on line 392? So let's just step through this. I know I could use a debugger at this point, but let's just, why start now? Yeah, I saw Stan give a really good talk at LRUG about using the new, or the newish Ruby debug gem. So maybe at some point I should train myself to use that rather than this kind of fumbling around with puts debugging. But it's really hard to unlearn stuff like that. Okay, so so what are we doing here? Getting table at index.inspect. Puts got table inspect, and then we'll say getting index at this should be table index.inspect. At index got index.inspect. So it's a little bit confusing that we're reassigning to that local. So now this is going to be getting function at index.inspect. So I suspect that what's going on here is that we're getting nil from the table. Let's see. I think that's what the error was suggesting. So yeah, getting table at index 0, got table. So we found a table, okay, but it doesn't have any elements. Which suggests to me that I haven't done any work to make this, you know, clearly when the module is instantiated, we need to splat these into the table, and I don't think I'm doing that. Also, we're not even making any attempt to initialize it to be the correct size. So hold on, let me think about. Sorry, I just got distracted by this. Support the register command. We did have to parse that here. Okay, I can't remember if we actually implemented that. Anyway, sorry, that's a distraction. It's just, I left it there to distract myself. So the things that I'm confused about what I'm looking at here. Okay, this is where we were. I think this is it. Sorry, I lost my place in this test, and that did my head in for a second there. So I think what we need to do is initialize tables to be the correct size, which involves actually storing their the limits from their table type. And I think this is what I'm not doing. I'm not 100% sure, but I certainly don't seem to have done this. Copy LMs into tables during module. Is it instantiation? I keep forgetting what the verbiage is here. Initialization. Yeah, instantiation. An active element segment copies its elements into a table during instantiation as specified by a table index and a constant expression defining an offset to that table. So yeah, that's the constant expression defining an offset into the table. So this is an active element. Yeah. Okay. So yes, I'm not surprised that that's not working. But this means that now we're finally getting into the meat of the semantics of this, the dynamic semantics. Because up until now, I've just been wallowing around in the parser for ages. So this does give us the opportunity to make this work, because we're getting the correct table, we're getting the correct index, but the elements aren't there because this table hasn't been initialized. So what should a table initially contain? Doesn't say here. Problem is, I just don't know. Okay. Let table type be the table type to allocate and ref the initialization value. Let table inst be the table instance with n elements set to ref. Okay, so where does this ref come from? I mean, my assumption here is that when we initialize a table, depending on the table type, the initial values, the initial values in the table need to be of the right type for that table. I just don't know where this alloc table comes from. Doesn't help that the search doesn't work. I mean, this here... is this trying to say? Sorry, I'm just trying to understand. Because this is talking about the abstract syntax of modules. So a module is sort of a record that contains all of these things. And it's saying that we construct this module instance by applying various functions to all of these bits and pieces of the module definition. And then here, this is suggesting that we always do that by calling alloc table with ref null here. Oh, right. So it's a null of the appropriate type. Okay. All right. That makes sense. Yeah, because the T here comes from the table type. So the table type's got limits, and then it's got like a ref type here, and then we use that. But I think for the purposes of what I'm doing, I'll just assume that, and I think I have assumed that ref null is probably represented by nil. This whole area is extremely poorly, like all of this stuff with refs I just haven't thought about at all yet. I mean, I've got these sort of dummy AST nodes that represent them, but I don't really know what to do with them. Yeah, so at the moment I'm just using Ruby nil to represent that sort of null ref, and you can see I'm just using the externref symbol to represent an externref. So this is all a bit of a mess. Okay. So I think what I'm going to do is, sorry, this is all a bit of a, I've gone a bit down the rabbit hole here, but I'm just trying to think about what should I do for this, initialize tables to be the correct size. Because it would be nice to be able to at least do that properly. And I think what that means in this case is having a table that's, well, that contains 10 nils. Because I think that here in the table type, yeah, the size, if you don't specify a maximum, the size is just the minimum size. So I think in other cases where, like here, when you get more than one thing back, at the moment I'm just returning an array. So with a type use, it can return, okay, in that case, the index of the type and also any parameter names that we found while we were parsing that type use, because the type use can associate names with the parameters from the type. Because there's always a function type, I think. So how do I want to deal with the fact that when you parse a table type, you get a min and a max, and this, you know, does this deserve to be like for memory, I'm just sort of packaging all that up as part of the memory, so it feels like for table, it should probably have something similar. you know, something like this. So yeah, I mean, this just doesn't return anything at the moment, but I'm sort of calling it up here as if it does. Yeah, I don't even know what this means. Like, why is this going into this array here? Yeah, this is all very messy, unfortunately. Just trying to think what's the least messy way to deal with this. What does parse global type return? Oh. That just returns a that just returns the like a string, the name of a type. What do I want to do here? Sorry, I'm not being very articulate here. I'm just trying to think, like, what do I want parse table type to return? I suppose it doesn't really matter. Why don't we have this just return minimum size, maximum size, ref type. Like, that's fine. So here, the minimum size is non-optional. So this should be, you know, we don't need to do repeatedly here. And this just needs to be if peak in no, it's a U32. Num or hexnum. Yeah, I don't really have a regular expression for that, so I guess it's just this, but this is not really right. So yeah, this is and limits. Because at the moment, this regular expression doesn't account for the fact that it could be it could be a hex num here instead of just a decimal number. Yeah, I mean, parse integer is just gonna, oh yeah, and well, it shouldn't have a minus sign at the beginning, but I think, oh no, U32 can't have a minus sign at the beginning because it's U. Yes, it's only S32 that can actually have a leading minus sign, but yeah, okay. So hold on. Okay, so now this needs to be minimum size, maximum size, ref type equals parse table type. And this is now minimum size, maximum size. Whether we'll ever need ref type, I don't know, but parse table type. So what's going wrong here? Parsing table type 10 func Yeah, that seems okay. Parsing table type func lm ref.func I'm not sure I know what's going on here. Let's just check that all of the existing tests are passing okay. Because if I've actually broken something, then that's a problem. But it might be that I've just, oh yeah, there is actually a failure here. Parse table type. Okay, well, what am I doing that's not right? Like I don't really understand how this could have. Let's just try this simpler change. Because I think that's kind of the same. No, but it's not. What have I misunderstood here? So for this, we can say minimum, and this can be maximum. So hold on, I've misunderstood something here. Is the minimum... There's going to be some kind of abbreviation that means that you can... Oh, yeah, okay. Yeah, so this is the difference, is that you can actually leave them out entirely. An element segment can be given in line with a table definition, in which case its offset is 0 and the limits of the table type are inferred from the length of the given segment. So actually the minimum, even though the syntax says that the limits has to include a minimum, actually there's an abbreviation here that says yeah, see the n here is the minimum and maximum size of the table, and the n is how many elements there are in the inline element segment. So I think, okay, that makes sense. Well, in that case, I just need to make it so that both of these are, I can see why I put them in a loop now. That's not ideal. I think that'll be okay though. Okay, so fundamentally that hasn't changed anything, which is what I wanted. So yeah, this is just adding, this is adding the minimum and maximum size to a table. Yeah, that's all just debug stuff. Let's start with that. Okay, so I'll just say add minimum and maximum size to table. Here we go, Etienne. This is your lucky day. And I'll say we need these so that we can initialize the table to the correct size during module. I've already forgotten. Initialization, instantiation. I'm sorry. I look up this word 100 times and I always forget. We can initialize the table to the correct size during module instantiation. Note that although the grammar says that the table type must contain at least a minimum and optional maximum size. The abbreviation, the limits themselves are optional when an inline element segment is provided. Well, they're not even optional, they're inferred. So yeah, it's not even syntactically valid to provide a table type. You just have to provide the ref type part of the table type and skip the limits altogether. So actually, it wouldn't be syntactically valid to provide them there. Okay. Thank you. I think you're saying good luck and have fun, maybe? I hope so. Thanks. Okay. All right, so I've got I now know the minimum and maximum size of the table. So that means that in the interpreter, see, at the moment it's just got the AST nodes. I think maybe I should do what I've been doing elsewhere, which is actually having a runtime representation of a table. Probably shouldn't be storing the name of the table here, because no one should need to refer to that. But in any case, we can ignore that. Minimum size, maximum size elements. And then what actually are the elements? Oh, so these seem to be just expressions. Yeah. Okay, so yeah, so I think if we're going to be serious about this, then we don't want the AST. What we want is an actual array in Ruby land that contains the result of evaluating each of these. So I think, yeah, let's just take the bull by the horns and actually do that. So here, let's say table equals struct.new. For now, I think I just need the elements. So I think this is going to need to be build tables. Something like that. Although I can already see that there's going to be another one of these problems where it's going to need to sort of initialize. tables. You know, because this isn't going to be able to this isn't going to be able to evaluate any expressions because we don't have a current module set at this point, so we're going to need to do this. We're going to need to do this afterwards. I don't know what information this is going to need. I mean, what does a module do? Like, there's a fundamental problem here, because what do we do when we parse these LMs? They're not stored in the module. So at the moment we just throw them all away. So that doesn't seem right, does it? So firstly we need to say like store LMs on module AST node, because at the moment they're just being discarded. So I guess that's a separate problem. So I'll forget about initialize tables for now. Let's just worry about build tables. And that's just gonna hold on. So how is this working at the moment? So how does this... Like this can actually just... It can just be an array of indexes rather than an array of expressions. Oh. Okay, so look, the only place that this gets called is inside parse table right now. So this is all about having an inline element segment. This is actually the only thing that we support at the moment. Those top level ones just get ignored. So this is not an inline segment. So we're not making any attempts to even parse this at the moment. We just skip over it. But what we do support is inline element segments, and this says LM so it looks like syntactically there are two different things that you can do here with these abbreviations. Is that right? You can either say table LM and then just give it a load of these lm so these element expressions, oh, items, okay. So that's what we're doing here, is looking for item. Is there some other abbreviation in play here? Oh yeah, just an abbreviation for item. So the item keyword is optional. Yeah, I remember. I think I implemented this recently. So, okay, so syntactically, when you're doing one of these inline element segments, you can either give it a load of these nested in brackets, these items, which are then contain an arbitrary number of instructions, or if you just want to provide a single instruction, you can omit the item keyword, which is confusing. Or you can just give it a load of function IDs, which are either numbers or like symbolic identifiers that start with $. And we make that decision by just saying, well, is the first thing that appears after lm, is it a bracketed expression? Because if it is, then we must be in this first case, otherwise we're in this second case. So it looks like what's happening at the moment is it looks like we only ever support this case. Like, this is what call indirect is doing, is it's expecting the elements of the table to just contain numbers that are the indexes of functions. And like, we don't seem to be making any attempt to actually evaluate, you know, what I initially went looking for here that I didn't really articulate or indeed even hint at, but I was thinking about it, was like, where do these element expressions get evaluated at the moment? And the answer is they don't, because it looks like the only thing we've used tables for is for the implementation of call indirect, and that is assuming that we're going to have this vector of function IDs, not this vector of element expressions, which these can just be arbitrary expressions. I mean, none of this is directly relevant to what we're doing here. I'm just trying to think how to set up the table initialization stuff correctly, basically. Like, this is expected to be a table of elements. I think building the tables is just about making like, I think this should just be something like tables.map. I think it should just be like table.new elements. I'll sort of make a new array. How does that work in Ruby? Yeah, you don't need to specify. So let's do elements array.new table.minimum size or 0, because that can be nil at the moment. So that's just initializing the tables to be empty. So this is what I wanted to understand, is like, instead of just copying the AST here, we can initialize these empty tables. Now, I think if I do that, it's going to break some of the existing tests, because now those tables are going to contain nils where they previously contained function IDs, because it was just using the AST directly, which can contain just raw function IDs or function indexes. So yeah, right. So here we go, exactly that. So this is where we were doing an indirect call. Now that table is not populated. In fact, if I retrieve that debugging code from the stash, then we should be able to see it. Oh, but really what I should be doing here is if the index is missing, if the minimum size is missing, then that means that we were given one of these inline. Okay, so, okay. So I shouldn't do or 0 here. I should do or table.elements.length. Like what I was expecting to see was an array with nils in it. Yeah, look. So I don't know what table this was from cool.wast, but this is what I was expecting, is that there's a table with a minimum size of 1 because we were given some kind of, well, let's just see if we can quickly find it. lm $func. So it was probably this or something similar. Oh yeah, it is this. This is the only occurrence of it. So yeah, this is the one element table. And in the AST, this func has been turned into the index of this function. But I haven't made any effort yet to copy that over. I've just made this runtime table that is empty, but it has the right number of slots in it. And so what I want to do, I think I am going to do initialize table. Like, at the moment, the only information I've got for populating these tables are these sort of inline element segments. But at some point, quite soon, in fact, this is coming up extremely soon, I'm going to have to start supporting these as well. And these are going to, we're going to need these during instantiation here to populate these tables, but these don't exist yet. So for now, we're just going to have to use these inline things. And furthermore, I'm just going to preserve the current behavior, which is to assume that they're all numbers. So down here, so it's sort of a similar situation to up here, where I'm going to say like tables each with index do table index, because each of these might have an inline element segment. And again, this is a situation where it's like I'm having to separately support the abbreviation, which I currently do support, and the sort of unabbreviated form, which I currently don't support. But just trying to get the abbreviation working, this is going to have to iterate over these table nodes from the AST, which are going to match up with, you know, current module.tables slice index. That's going to be the corresponding table. So I'm not sure what the right thing to do is here, but this has got me the sort of the runtime table. Maybe what I want to do is say like table elements I'm just trying to think about how I want this to work. Like for now, I just want to copy them over because they're numbers. So case element in integer, table instance elements element index equals element. So this is just copying over. If we are in this situation where there's just a bunch of numbers, this is just going to copy them over, he says confidently. Right. So that's fixed that problem now. Now that table was populated with, instead of just containing nil, it contained 53. And when it got the index at index 0, it got function index 53. So getting function at index 53. So it all worked. So let me just think about what I've done here. Okay, let's think about what I want to add. And yeah, this is the case where if there's some kind of expression here, if there's an instruction rather than a number, well, in fact, it's going to be an array of instructions, isn't it? Yeah, because these can be expressions. Yeah, this lm expr in general, this here, an expr is just a list of instructions. So yeah, this is either going to be an integer, in which case it's just a number that I can copy over, or it's going to be an array, in which case it's an array of instructions that I need to evaluate, and then whatever value ends up on the top of the operand stack at that point becomes the value that goes into the table. Okay, but I don't need to worry about that yet. So, okay, but that not only has that not broken, well, let's run all of the tests to make sure that hasn't broken anything that wasn't already broken. Okay, so that indeed has not broken anything that wasn't already broken. So I think I'm safe to add that. Yeah, so this is going to be something like introduced runtime representation of tables. And then I'm going to say, whereas previously we were just storing the table AST, now we're building an empty table of the correct size, minimum size, either specified explicitly or inferred from the length of the accompanying, well, the inline element segment. And then populating it with the contents of any inline element segment. At the moment, we only support integers, i.e., do they have to be function indexes? Yes. In the inline segment, but later we're going to need to support arbitrary expressions, which is why we need a separate initialize tables method that we can run after the current module has been set. Well, it's actually current module. I've broken out. That's why I've broken out a separate initialize table method that can run after current module has been set. Yeah, okay. I think that's right. Okay. So I've done this now, initialize tables to be the correct size. So I wish I hadn't thrown all that table debugging stuff away, because I've realized that I still want that. So that's in, I could have saved it just then, but I didn't. Okay, so the reason I had all that there in the first place was so that we could see what was happening. Ah, right. So it turns out that we're already somewhere in this test, we already have an inline So when this module gets instantiated, even though there are no assertions, oh, hold on. We don't care about that. We just ignore that. Okay, so let's look at yeah, here's the problem. So this is trying to So the reason I'm pausing is because, I mean, at the moment, I think this at the moment, we don't even know how to evaluate this, and there's no information stored in it. I mean, ultimately, what we need to do here, well, that doesn't super matter, but because there doesn't appear to be any assertion about this, this is just testing syntax, but like more generally, what we need to do in this case is to evaluate each of these expressions. These are actually just single instructions, but in general, they can be expressions. And the problem is that I don't have any notion of what it means to evaluate one of these expressions at the moment. Ref.func. I mean, clearly, what this lets you do is store a reference to a function. Quite why that's different. I mean, I don't quite know whether so this can be a vector of element expressions, or it can be a vector of function IDs. So I suppose what I need to understand is, what does this mean? If you just give it some function IDs, do you just get, is this just shorthand for like a load of ref funcs? Let's find out. Oh, yes. It is an abbreviation. The element list can be written as just a sequence of function indices. So actually that is an abbreviation. So I'm just thinking about what I want to do about that. Like ref.func always just contains a function ID. So it's really just a wrapper for a function ID. Sorry, I'm just thinking about what. I'm just thinking about what I want the underlying representation of this to be. Like, when you evaluate ref.func, what should that in fact return? Can it just return a number? Like literally the function index? Like, I mean, is this... Yeah, it just says produce a reference to a given function. So yeah, the question is, what do I want the runtime representation of a reference to a function to be? Can I just allow it to be a number? And then this only shows up because of type checking, we'll only get one of these numbers in a situation where one was required. I think I'm going to sort of try it for now and see what happens. It makes me realize that maybe the simplifying abbreviation here is in the AST parser. Like, this is detecting the case where it's just func refs. So maybe what I should do here is actually make this oops. You know, do something like this where it's like, not articulating this very well. At the moment, this can return either an array of instructions, or it can return just these like mystery numbers. But I think maybe if I wrap them up inside these ref.funcs, then that makes it clearer. You know, when you evaluate a ref.func, what you get is just a function index. So what do the... Let's just see what the evaluation rules say. So yeah, here it says it wants it to be a function address. That ends up on the stack. But I mean, we can represent that. I mean, I assume that the only thing you need to do with a function address is to be able to call that function. Okay, I'm getting a little bit tied up in knots here. Let's stash this. Which is a good thing to do whenever I'm getting tied up in knots. Okay, what order do I want to tackle this in? I mean, essentially, this has thrown up a new problem. And hopefully one that we're not already seeing. But the fact that we're no longer... Like previously what was happening was that when we instantiated this module, we just held on to the AST nodes for all the tables and didn't try to do any kind of initialization, instantiation. We just held on to them. And so as long as we never, as in this case, as long as no one ever looks inside this table, nothing bad happens. Whereas now we're trying to proactively convert this into a runtime representation. And then at the moment, I don't know what to do with these bits and pieces. Okay, so it hasn't directly broken any of the existing tests. So I think the way to get the correct error message at this point is to do the work here, which is let me just understand what can appear syntactically here. So it's element segments we really care about. I mean, this just says expr. This is just like arbitrary expressions. So there's nothing... There's no constraint on this. It doesn't need to be like a constant expression, for example. Like this is just arbitrary instructions. And, you know, I don't know, but I assume well, hold on. Each element segment defines a reference type and a corresponding list of constant element expressions. constant expression, all instructions must be constant. I'm not sure I understand how this works. Like, what does it mean to have multiple instructions in a constant expression? I don't understand that. I don't understand what... this is a bit baffling. It doesn't say anything here about them needing to be constant, but it was pretty clear. I mean, the main thing I want to know is, like, what do I do here? If this is an array of instructions, then like, can I just evaluate expression? What did I do up here? Yeah, this kind of business. Evaluate expression global.value. You know, evaluate expression element. And then, you know, essentially this. Like, I'm really not sure. I mean, let's just assume that that's what you're supposed to do. I'm almost, well, no, not almost. I'm very reticent to look at this execution part of the specification. I just find completely impenetrable. For each element segment, let n be the length of the vector in it. Execute the instruction sequence. Oh, that's to get the offset. Right, so in it is this vector of expressions. It's lm.drop. What does that do? Oh, God. Okay, so this is... I can't see where these instructions get executed. this is just too obtuse. Okay, well, I'm just not going to bother trying to read this. Okay, so I'm not getting any joy from that from that particular part of the specification. For now, I'm just going to assume that this is what you're supposed to do, that you're supposed to evaluate the expression, and then it's supposed to leave a single value on the top of the stack, and then that's the value of that element. But I don't know. That's what I did for globals, so how wrong can it be? Okay, so now this is what I wanted to see, was I don't know how to execute the ref.func instruction. So let's say evaluate element expressions. That's inline during module. I can't believe I've forgotten what it's called. Instantiation? Yes. And let's say none of the currently parsing tests try to do this, but lm.wast does. We'll need to actually be able to execute the ref.func instruction before this will properly work. Okay. So yes, this is what I was trying to do here, was say, well, we could get rid of the check for integers by making sure that you always get an expression here, but at the moment this won't work yet, so we're not quite ready to do this. What we need to do to make it work is make it possible to actually evaluate this. So let's say, I think the right thing to do is to say that ref.func needs to remember the function index, and then when we parse it, this is not a read, it is a parse index. Index context.functions index. Does that seem right? So let's see what that does. Okay. So we're getting there. It's got the right index in it. So this is just add function index to ref.func AST node. So now I've got to make that decision about what the runtime representation. Well, I mean, firstly, I've got to be able to actually implement this instruction. So in ref.func, do we just match? Yeah. So the error previously was no matching pattern error. Now there is a match, but the stack doesn't have the right number of values on it now. So I think I'm just going to push the index onto the stack, the function index, which is all a little bit loosey-goosey. Like, that's just how I'm deciding that I'm going to represent the address of a function, is just by its index. Unless... I mean, we do have function objects, don't we? So I could, if I really wanted to, this, instead of pushing the index of the function, I could actually push current module .functions.slice index. Like, that would also be legit. Oh, it's saying the index is nil. Index is 0, index is 1. Oh no, hold on. This was a different... That's a different problem. Right. Okay, yeah, this is the existing problem. This is the fact that we're not doing anything with the... We're not doing anything with the top level element segments, only the inline ones. So that's okay. So I think this is all right. I think what I'm going to do is push the index. Yeah, there is a temptation here to actually just push the function object. Which would then have to be dealt with in the call indirect up here. Because at the moment it's expecting to just find a number here. But if when it did table element slice, it could actually be retrieving the function rather than the index of the function. But that's something to think about in a minute. So I think that so I think this is really implement the ref.func instruction. At the moment, we just push the function index onto the operand stack, since that's what the implementation of call indirect expects to find in the table. But I don't see any reason why we couldn't push the actual function instance onto the stack instead. I might try that once everything else is working correctly, because an anonymous index on the stack is going to be harder to debug and understand than an actual function instance. Okay. Okay, so I still haven't done either of these. So what I'm curious about is whether I can now just safely do this. Like, if I'm no longer storing raw numbers and I just store expressions, ref.func expressions, then do all my existing uses still work? Because if they do, I can remove that case that's expecting to see numbers maybe, and this would be a more honest implementation of this abbreviation. Element segments, abbreviations. So essentially, this is what I'm doing. If I just find a list of function IDs syntactically, then I store that in the AST as an array of ref.func instructions. So this is a circuitous way to communicate those function IDs to the interpreter, but I think it's more regular. Def build tables. Initialize tables. So effectively it would mean getting rid of this. So again, let's try that, because I think this is a self-contained change if it works. And it was just waiting on an implementation of that ref.func instruction that was able to dump, well, at the moment, just the index of the function onto the operand stack. But as long as call in direct knows what to expect here, it could be, as I said, a function index. Function object, sorry. So actually, I guess this can be added into two independent pieces. Yes. So I think everything is broken in the correct way still. So this can be store function indices as ref.func expressions in inline element segments. Because I think parse elements Yeah, it's only, at the moment, it's only called for inline. This should probably be called parse table elements because I think the syntax is different, or at least it's safe to assume that it's different. This better matches the nature of the abbreviation. Oops. Well, I thought I had something in my clipboard, but I definitely didn't. Some of these URLs look not particularly reliable. Element segments, ID 7, ID 8. Okay, well, I just got to live with that. And means we'll be able to stop distinguishing between function indexes, i.e. integers, and expressions, i.e. arrays of instructions, when initializing table contents in the interpreter, because now every item is an expression. I hope item's the right word. Yeah, that'll do. Okay, and then here is that. And then we can say stop distinguishing, wishing between indexes and expressions. In build initialize tables. Let's just say per the previous commit, the parser now always provides an expression for each item, possibly by generating a ref when expanding a function index abbreviation. Okay, so this is one place where, because it's sort of local, we are able to just sort of expand an abbreviation as part of the process of parsing this, and then that regularizes the work that the interpreter does. Okay. Now what? So I mean, that was just cleanup. I think now I need to do this, because we're back in this problem now where we've got a nicely initialized table. So let's just remind ourselves of what the code does. Yeah, this was it. So we've got this nice table with 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slots in it. That's worked. And then we're dutifully trying to retrieve, well, we're trying to call the function whose, yeah, and this is a ref.func, isn't it? Trying to call the function whose reference is stored at location 7, but this is all just thrown away by the parser. So we've got to make an AST node for that. So I'm just going to call this element. It's really an element segment, but what's this going to need to store? Okay, well, so potentially offset. Potentially a table use. I mean, none of these hold on, what's that? Oh, so you can actually associate an ID with an element. What is that? Table init. God, I'm going to need to understand this, aren't I? Okay, well, elements can have a name. I'm not going to store that. It's going to go in the identifier context, I think. Yeah, so the identifier context is going to keep track of that. So that's another piece of work to do. That's an offset. I mean, I'll just try and get working the one that I'm looking at right now, which is, it doesn't have an ID, it does have an offset, and then in this case, it's just got a function ID, a function index. So yeah, let's just support that syntax, and then I can build it out. So yeah, this one doesn't have a name. It does have an offset. How is this able to emit the ref type? If the table use is omitted, the func keyword can be omitted as well. So I think what we're seeing here is it's this abbreviation again. So you can say func vector of function IDs, and that's an abbreviation for func ref is the ref type. Oh God, this is hard work. Okay. So really what this should be saying is func $const, you know, that's what all of these are doing. Func $f$g. So it's very much like this one. LM, it emits the table ref, and then it is offset, and then func $f$g. But we've established that the func is actually optional there. A table use can be omitted defaulting to 0. If we just say, oh, I guess this is the abbreviation we're talking about. If we just see LM offset, and again, the actual offset keyword is optional there, and then we just got a vector of function IDs, that is like the word func was put there. Okay, and it says that's for backwards compatibility with earlier versions of WebAssembly, but this test is has apparently not been updated since that earlier version of WebAssembly. So anyway, this is some syntax we've got to support. So I mean, I think I should just be laser focused on getting this assertion to pass, right? Because this is enough to be getting started with, is to be able to parse both of these, heed them during the initialization of the module, the instantiation of the module, and then that will make these two assertions pass. So let's just do the minimum possible here, which is I'm going to need to store the offset, and I'm going to need to store, well, I've already put offset there. I suppose this was all just me trying to understand what do I want to store here. I think I'm just going to call it items. Let's have a look in structure here and talk about element segments just so I can get the words right. It says init. It's the vector of expressions. Oh right, a passive elements can be a passive element segments elements can be copied to a table using the table.init instruction. So here we don't need to do that because this just happens by magic during module instantiation. Because an offset is provided here. Whereas well, I can't remember where we saw init. But that's something we're going to have to deal with later. For now, I'm just going to assume that all of these, given that I've just been ignoring these LM fields, I'm just going to assume that they're active. Yeah. So they're going to copy themselves into the table that they're referencing. And in this case, they are not even referencing a table because they're just implicitly referring to the first one. So yeah, I've just got to keep... See, I'm normally quite good at this, like keeping the scope as narrow as possible to just ensure that I'm able to keep my head straight. But I find myself being constantly pulled away from that. Like every time I look at the language specification or every time I look further down in this file, I'm like, the size of the problem is sort of expanding in my head, and I have to force myself to kind of narrow it back down to this one thing that I'm trying to do. So yeah. I'll call these items for now. I don't know what the right thing to call them is, but the name doesn't really matter, so I'm not going to sweat that. So at the moment, so yes, I can ignore this, but at some point I'm going to have to deal with the fact that there can be an ID in here and it needs to be added to the initial identifier context. But here, yeah, so this is this was for the inline. So let's call this parse table element, because it's really an element segment. Just to make room for that name. So let's just say this is specifically for parsing inline element segments inside a table definition. So its name should reflect that, this method. For parsing an inline element segment inside a table, so its name should reflect that. It's also singular because a table can only contain one inline element segment. I hope that's true. Let's just check. Oh. Yes, this isn't one of these recursive abbreviations. You can only put one LM in here. Okay, that's a relief. Okay, so now I can have parse element. I'll just stick it on the end here. So what am I going to need this to do? Oh yeah, so that whole thing is optional. So what does one of these look like? Right, so we're already inside the list here. I don't know. I keep going back there to see if there's something useful, but there isn't anything useful because this is different. So do I already have... No, that's different syntax. Right. So it is a little bit like this, isn't it? So at the moment, I'm not entertaining the possibility that the offset isn't there. But what I am doing is entertaining the possibility that offset might be missing, because this is one of those situations where if it's a single instruction, you don't need to put the keyword offset. It can just be a single instruction. So I might as well permit that here. So we've read the LM. We've read, in this case, a single instruction, but I might as well support the idea of saying offset and then having multiple instructions. And then I think this is just going to be what else do I need? Items. It's like items equals repeatedly it's like parse index context.functions. Oh, but again, this should be, I should expand the abbreviation in the same way by wrapping it in a ref.func. So this should be ref.func.new index. Oops. I think that's right. And then this can be element.new. Have I got all the right things? Oh yeah, it's just offset an item. So items is going to be an array of expressions, which in the case we're dealing with here can only be function references. And the offset is going to be an expression, which in this case is just a single instruction. So I think if I run this test, it's going to fail because it doesn't have any way of storing these in the module. Yeah. Okay, well, it doesn't even have a local variable. So, was I having these in any kind of sensible order? Don't think so. It was just the order I got around to doing them in. Functions, memory, tables. Elements. Okay, and then I'm expecting to get a complaint about the module AST node constructor, not knowing what to do with elements. Oh no, not a list. Func ref. Yeah, okay. So, okay, how do I want to approach this? I think I want to approach it by taking a copy of this file for now. Because the problem is there's loads of variations on this syntax in this file. And previously, because they were just being ignored, it was not causing a problem, but now it is causing a problem. So let's narrow it down to the thing I'm actually trying to get working. And then at least that'll sort of focus the mind a little bit. Once I've got this working, I'll broaden it out to how do we expand this parse elements to support other syntaxes, because you can see there's all kinds of stuff we need to be able to deal with in here. But now that I'm taking it seriously, I just want to take this specific syntax seriously first. So I'm going to just try running this. Right, like I said, module constructor is not happy. So elements. Right, okay, so we're back where we were. And let me just check that. Oh, why's that happened? Oh, it's because of parse binary fields, isn't it? I always forget about this. What do I want to type here? Elements. Okay, yeah, that's exactly the kind of thing that I thought I might forget, and I did forget it. Specifically the binary module parsing, not the word elements that I've already typed 100 times in the last 10 minutes. Okay, this doesn't seem to have broken anything, which is a relief. Yeah, I mustn't commit all that. All that puts debugging, ideally. Okay, pending test failed successfully. So I think I can just add all of that. So let's something like try to parse element segments when building module AST node. And I'll say at the moment parse, oh god, element only supports an extremely narrow subset of lm valid lm syntax, because I'm focusing on trying to get the very first use of it in lm.wast working. Okay. So we haven't got any further, except, you know, this is all still empty, but now we've got a hope in hell of actually populating it during initialized tables. So now we can do this, make those elements available. Again, at the moment, I'm not distinguishing between passive and active segments, although I think the distinction is just syntactic. It's whether they've got an offset or not, right? Yeah. Yeah, slightly strangely, it's that simple that syntactically you just have to provide an offset. And I remember getting confused about this before, that the table use is effectively optional. Yeah, because it defaults to table 0, so you can't rely on that being present. But yeah, it's the presence of, and the offset keyword is optional, but ultimately, if there is an offset, then it's active and we need to copy it into the table. So maybe I can, there's no reason why I can't heed that in here and say, like, find all of the elements that have an offset. And I think at this point we're also going to assume it's the first table, because I don't have a table use stored on the AST node. So this is doing all of the inline initializing, and now let's say elements each do element. I don't think the index is germane. So element offset element items. So is the idea that these get copied into the table starting at that offset? Copies its elements into a table during instantiation as specified by a table index and a constant expression defining an offset to that table. Yeah, I mean, I assume that that's what we do. We just iterate through. What's a nice way of doing that in Ruby? So let's say table instance equals current module.tables.slice0 to do table use. So this is, in general, we're going to need to choose the correct table because an element segment can refer to a specific table, but I haven't implemented that yet because here it's just implicitly referring to the first table because it doesn't specify. So the fact that it doesn't specify which table is, I'm just going to default to this one. So we need to, well, maybe the easiest thing to do is to say element items, each with index, do item index, and then we can always add the offset onto the index, right? So whatever happens in this block, the punchline is going to be table instance dot elements index plus well, let's call this item index. Let's say element offset plus item index equals value. And then the only question is what's the value? And I think the answer is something like this. Evaluate expression item. This is going to be an array of instructions. So I think this is right. Oh, of course, element offset is also an expression. Right. Okay. So I can't just do that. Okay, let's try again. Oh my word. Okay, so you can see that as prophesied, I assume that this is 0 indexed, in which case this is actually position 8 and this is actually position 10. We're supposed to be passing in references to the first function in this module in the 8th position, and the second function in this file in the 10th position, and that indeed appears to be what we have in this array now. So the table contains mostly nulls, but then it's got references to those two functions. And it all worked. So that's amazing. Let me run all the tests again to just make sure I haven't, broken anything, but oh, so I forgot to test to see whether the offset was present, but fairly obviously this is going to blow up if there is no offset. So for now, I'm happy with that. And then when that causes an error, that will be my incentive to come in here and say like elements select element.offset is not nil, or elements reject element offset nil. So that we're only dealing with the active element segments. Okay, great. Yes. Okay, I think that's all fine. So how do I want to describe this? Copy active element segments into table during module instantiation. Oh. Any element segment which specifies an offset is an active segment and must have its items copied into a table when the module is instantiated. We haven't needed to support passive or declarative segments yet. Okay, I think I genuinely don't need that anymore, but I'll leave it on my stash briefly because I already regretted throwing it away once. So here you go, store elements on Module AST node, copy LMs into tables during module instantiation. So I've done that now. So these two small assertions do pass. However, we've got the wider problem of supporting all of the different syntaxes in here. So yeah, firstly, so exactly how optional is this? So before I look at it, let me think about it. I think it's essentially non-optional. It's just that one piece of backward compatibility that allows you to leave the func out, I think. Let's double check that. Yes. If the table use is omitted, the func keyword can be omitted as well. But normally, after you've tried to read the ID, which I haven't even thought about yet, you always end up reading the element list. And the element list, in principle, always begins with funcref or externref, except in the case where we could write func. That's a special case. Well, for now, let's just make it. I mean, these types essentially don't matter at this point because we're not doing anything with them. So, I mean, so what order do things come in? we read an ID if there is one, we read a table use if there is one, we read an offset if there is one, and then, so this is we read an offset if there is one, and then this is just if can read list. So that whole thing has to be conditional because the funcref business comes after the offset. So we have to be able to not read an offset and then if peak in what funcref, or I guess it is externref. Or func, which is the special abbreviation, then we read it. So that's just skipping it. So that should deal with the read list, not a list funcref. 586. Okay, so yeah, we're trying to repeatedly parse index. Which is not right, is it? Because that only works if we've got this. So we need to do another thing where it's like, if we can read list, yeah, I mean, actually, there's a little bit more information available to us about whether that is going to happen. So let's say, what is this called? Reftype. So essentially what we're doing here is saying, like, at the right time, we're going to provide the opportunity to read the ref type, which can only be funcref or externref. And it also, because of this abbreviation, it can potentially be func. And in fact, it can also potentially be missing entirely if the table use was omitted. So that's a bit of a wrinkle. So let's say to do only if table ref was omitted. So this is the thing that allows us to allows it to be implicitly func. And if it's func, then that still means funcref, but I think it's useful for us to know that we've read func here, because that's what allows us to decide how to read the items. This is what I was getting at, really, is that if the ref type is func, either because it was said explicitly, as in this case, you know, here, func, or if it wasn't said at all, as in this case, then we know that we've just got to repeatedly read. We don't actually need to peek ahead. Like, we've got all the information we need. And in fact, I think this is something that I didn't really realize when I wrote parse table element, because here I'm sort of trying to, maybe for the inline, abbreviation, Yeah, see, I don't think this gives you the same... This doesn't give you the same, like, syntactic information. Because it looks like... you don't get the choice about whether... You know, you have to put func type or func ref or extern ref in here. You can't... It doesn't look like this supports that backwards compatible abbreviation shenanigans that's supported here, but actually in this case it's kind of handy. Basically, if you've said func ref explicitly, then it can't be an array of identifiers. You either need to have said func explicitly or you have to have not said anything. So here we can say items equals case ref type in func, do this, in func ref or extern ref. I don't know what we're going to do here, but we're going to do something else. Well, if I repeatedly read, parse element, no matching pattern error. Let's see how far this gets. Not very far at all. LM func ref 592. Ref type is nil. Why has that happened? Oh, because... Right, because this returns nil. Yeah, that was very silly of me, wasn't it? Okay, well that pattern match was completely unnecessary anyway. Okay, so that's working okay. So lm func ref, func. Ref type is func. Oh yeah, okay. So we need to be able to parse the optional ID there. What do I actually want to do here, though? The same thing as in parse table. I don't see any use of item here, but yeah, okay, there's item. It's essentially this. I mean, it's basically the same as this. It's just that we're making a decision differently because we've got more syntactic information in an explicit segment. maybe it makes sense to do that afterwards, because that's what I did here. So I'll just sort of reproduce the same situation here. Func is sort of a weird case. So we don't need these stinking putses. Okay, so let me just run the test to make sure that I haven't made any silly mistakes, but I mean, this is quite... Okay, well, there's certainly a few things here. It's a little bit too difficult for me to bite off in one go, I think. Let's just let this run through now that I've started it. Okay, so it hasn't broken anything. I'm just going to stash that for a second because I want to think about what the different steps were here. So this is if can read list. So this is make element segment offset optional. I think that's probably uncontroversial. Even that makes this diff a bit more tractable, right? And I think now it's easier for me to just read this ref type. So I think this is going to require a bit of explanation. Good old ID 7. So what am I going to say here? Read ref type, read element segment ref type if present. Let's say it can't really be func, but this is valid. It can't really be func or missing entirely, but these are both abbreviations for the case where a sequence of function indices is given instead of element expressions. So now it feels like we're getting closer. Yeah, and this is something like use use element segment reftype to decide how to parse element expressions. If it's func, we can parse a sequence of function indices. Otherwise, we need to parse a sequence of item expressions. As also seen in the parse table element method. I think that's right. Yes. Okay. So how much progress have we made? Right, so now, yes. Don't know if I need that yet. But the problem here is that we're getting hung up on a P1. So before we try to read the offset, we need to try to read I'm just thinking about whether I want to leave ref type as nil if it wasn't provided, but I guess saying it to func is making this code easy to write for the moment. I want to come back and I need to think about how to deal with this nicely. Yeah, I mean, this is the complication, this to do. You can't universally omit the func keyword here. You can only omit it if you've omitted the table ref, and we just haven't dealt with that yet. Okay. So that's the thing that will read the ID. Okay. Table. So is it trying to treat this? Yeah, I think it is. So yeah, we haven't dealt with the table ref, as I literally just got finished saying, and now that's a problem. Yeah, so it's oh, actually, it's trying to treat this as the offset, I think. What's it actually trying to do? Yeah, it's like trying to parse it as the offset. But it shouldn't, because it starts with table. So table use always starts with table, Please let there not be an abbreviation. There isn't. The only abbreviation is it can be missing entirely. But that's fine. I can deal with that. So, okay, hold on. Where am I at? I keep forgetting to add things as I go, and then I have to go back and reconstruct my history afterwards. So this is read optional element ID in parse element. Okay. So now after the ID, there can be a table use. So yeah, and that's optional. So yeah, there's sort of an interesting thing here where, like, if the table use is actually provided, then the offset becomes required. Because this is the only syntactic form where you're allowed to provide a table use. If you provide a table use, then it's definitely an active segment. And in that case, there's definitely an offset. I'm just not quite sure how to capture that in the parsing. Maybe it's not important. Well, let's say table use equals if can read list starting with table, read list starting with table, and then you get a table index. So I guess this is parse. So this should really be table index. Yeah, and then it's just this. So it's slightly different. Well, it's very different. But if can read list starting with table, read list starting with table do, parse index context.tables. Yeah, I think that's right. And then what did I say about offset? Sort of saying that it's, so really here I would say okay, I'll change that in a minute, because yeah. The decision about whether to read the offset, at the moment, we're just making it based on whether it looks like there is a list that we could read the offset from. I mean, is that even right? Not really. It's not really right, because it could be a passive segment. Oh, but then that would need to start with a ref type. Right. Yeah, maybe it's okay. Maybe it's okay. But we could certainly be more explicit and say, like, if you've supplied a table index, then there has to be an offset. It's not optional. But we don't actually need to do that yet. I'll do that in the next commit, because we can also clean up this at the same time. Okay, so does that get us over this hump at least? Right, okay. So finally, we've got a problem with a non-decimal index. So that's a whole new problem. What have I said here? Read optional table index in parse element. Again, no, I don't think this can be. I don't think this can be. I don't think we've seen this before. I'm just being very careful to make sure that I'm not breaking any existing tests as I do this, but I don't think I am. Yeah, I'm pretty certain that we've never seen this before. It's just, yeah, the problem is I used to ignore this syntax altogether, and so I don't have 100% confidence that that syntax has never showed up anywhere. But I'm pretty sure it would have blown up before now if this LM syntax was being used anywhere else. Yeah, and indeed it hasn't been. Okay. So what I'm doing here is I'm forcing the presence of a table ref. The presence of a table ref is forcing us to read an offset. And it's also only allowing us to do the abbreviation of an implicit func if the table use was omitted. Oh, okay, maybe I need to do that in 2 pieces. Let me just check that that hasn't created any new problems. No, same problem as before. So this is force parse element to read offset if table use is present. And yeah, sorry idea. The presence of a table use indicates an active segment for which an offset is mandatory. Yeah, I think that's enough. Okay, and then this only allow implicit func if table use is omitted. I just realized, like, I've been spelling it table use. Well, let's spell it like this. The presence of the table use indicates an active segment for which an offset is mandatory. Okay, and then what was I typing here? Only allow implicit func if the table use is omitted. And I'll say again, well, not again. The abbreviations for element segments allow the func keyword to be omitted only if the table use is omitted. So we shouldn't allow it in general. Well, let's say, so we should raise an error if there's no func or valid ref type under any other circumstances. Okay. All right, that's fine. Still nothing interesting in my stash. I'll get rid of that shortly. Okay, so finally, so index regexp needs to be more permissive than this. So what can U32 actually look like? It can look like a decimal number. Well, hold on. An index can be an ID, which we've just said is a dollar followed by oh yeah, anything. Okay, because this has already been sort of tokenized effectively. That's what read returns. So what does the syntax of U32 actually look like? Num. So it's potentially underscore separated digits. And potentially underscore separated hex digits. And it can start with a 0x. So what did I do? I don't want to go too far down the rabbit hole here, but I think it probably is in float.rb. What did I do? So here I did \d underscore !d star. Let me just copy these. I'm not going to do anything as elaborate as these, but I just want to maybe it is time to at least reformat this. That's not super readable, is it? Is this at least? Oh no. Oh yes, okay. It's very important to mark this as extended. Otherwise that is a completely different regular expression. Okay. Let's assume that's working okay. We need to add support for... We need to have better support for unsigned, for the syntax of unsigned 32-bit integers. So this regular expression is going to get a bit more complicated. It'll be easier to read as an extended. I don't know if that's what X stands for actually. When it's split up. More white space will make it a bit easier to read, like the syntax regular expressions in WASMinner float. Okay, so let's think about what we actually want to change here. So instead of \d, let's do \d underscore !d star. Sorry, I just realized I want to do that. Just sort of separating out the different parts. So this is something like allow underscores in index integer literals. In decimal index literals. The grammar says these are allowed. And now let's say ox hash is another option. So I'm just pausing because we need to make sure that we give it the right base when we try to convert it. I think I've basically already got this in parse integer. That's the reason I'm hesitating, is it's like, haven't we already done all this work? Oh yeah, okay. So I was just like wondering why we need this regular expression in the first place, but there are places where we use it to decide whether an index has been provided, because it can be optional. It looks like there's only a couple of places. It's just in BR table and call indirect, but that's enough that it's worth having a reliable regular expression to make this decision. So this still isn't right because I mean, what even happens if I say ox AA to I base 10 get 0? Okay, well actually I think the number in question is 0 here, but I think what I'm going to do is just wrap this all up into a single change, because it's sort of nonsense otherwise. So just something like this, right? Right. I think this is more accurate. Add support for, what did I say? Add support for hexadecimal index literals. Yeah, I don't think there's anything particularly interesting to say about that. Okay, so now there's a new problem, which is that we're trying to match declare. So this is a declarative. So yeah, we've got actual syntax for saying that it's a declarative element segment. Declare. So if that was going to come anywhere, I guess it's after the ID. And then we have to go straight to the element list. I mean, for now, I think I'm just going to skip it. If peek in declare, read declare. Okay. So that looks like we successfully parsed it. Oh, yeah, the problem here is that we're trying to evaluate a nil offset. So that's kind of what we expected. So let's just say ignore declare keyword in element segments for now. Yeah, I don't want to say any more than that. I don't think these are actually used. Yeah, let's say for the purposes of lm.wast, we just need to be able to parse these. So it's enough to ignore the keyword for now. So it's currently enough to just ignore the keyword. Okay. So now here, let's say I think I said before, elements reject offset nil. So I think we should just skip all the ones that don't. So this should give us only the active element segments, right? Which is what we want. So this is odd. It looks like we don't have any tables in the current module. Current tables. So like all the way through in general, there have been current tables, but here so what's gone wrong here? It's because there's an imported table. Okay. I mean, this is pretty relentless, but it is shaking out a lot of stuff, so I shouldn't really complain. Okay, well, okay. Let's say only try to copy active element segments into tables. And let's say an active segment can be identify, let's say only active segments have offsets. Only active segments have offsets, and every active segment must have an offset, basically. That's not a very good explanation. Let's say a segment is active, i.e. gets automatically copied into a table during module instantiation if and only if it has an offset. Okay, that's a slightly better explanation. Well, look, I'm going to give myself a free one here. When parsing indexes, support hex notation, tick. I haven't yet done that when parsing limits. Okay, like flesh out dummy ref.func. Again, I mean, this isn't just to-do list inflation, it's also helping me to keep track of which of these I've actually made inroads into rather than things that I haven't even vaguely thought about. Like I actually have done ref.func. Let's say consider making ref.func return a function object instead of an index and fix up core indirect to expect that. So, is it now possible okay, so where's the yeah, I mean, I guess this is going to be the problem, isn't it? Like this basic use here is trying to import a table from spectest, and then it defines a function, and then this is an active element segment that tries to store a reference to that function in the table, and there is no table, so that's not going to work. So how could I make this work? Because in all these other build blah blah, like I think I need to do something like this, right? Or like this. Table imports equals imports.select import in kind table. Module name, find module, exports, fetch name. So that's all the same, which is motivating this to-do list thing that says extract interpreter helper for resolving all imports of a particular type, because I've just copied and pasted that code and put table in there of a particular kind. So now could this just be table imports plus tables map oh yeah, of course this is just using the AST node. It's not, there's no runtime function representation yet, whereas I do have a runtime table representation that's not just the AST node. That's why this is different. So this isn't going to magically work. Oh, or even slightly work, because you have to supply the imports. Key not found table. Well, what I was going to say was it's not going to magically work. Because I don't think I've set up, I don't think I'm exporting a table from spectest, because I was just adding stuff as I needed it. So I should have finished that thought 45 seconds ago. But I was typing instead of thinking. So yeah, I think this. So let's do that. I'll do it in the same order. So globals, table. So it's called table, table.new, elements, array.new 10. So it's just going to be filled with nil by default. Oh, hey. So we're still not done, but like, we've got quite a long way. Like, let me take out that debugging code. Yeah, I mean, admittedly, all but 6 of these assertions are skipped, but we're way further into this than we previously were. I'm just going to run the whole test suite again to increase my confidence. Okay, well this is 2 changes. include imported tables when instantiating a module. And then this is going to be add table export to spectest module. Okay. Pending test failed successfully. So, right, so we've added the ability to parse the register instruction, but not the ability to execute it. So this is a command at the level of a module definition or an assertion or whatever. So it's this sort of top level evaluate script business. Command in AST module, in invoke, in assert return, in get, in skipped assertion. Oh no, get is an action inside assert return. Right, okay. I'm just trying to decide where to put register. I suppose I'll put it at the bottom, for want of a better place to put it. Don't know how to register. Let's just check that control flow is going there. All right, don't know how to register. Okay, I've done that in the right place. Okay, so register module for imports. After a module is registered under a string name, it is available for importing in other modules. So support the register command. Remember that we need to separate module IDs used for invoke and module names used for import. Okay, so yes. So I'm not sure to what extent we assert return, find module, module name. So yeah, I mean, I guess in both invoke, oh yeah, sorry, what am I talking about? Of course it uses a module name. It's just because it wasn't after assert return, but yeah. So assert return has got magical powers which allow it to reach into a module that's got a sort of a private name and invoke stuff in it, whereas register lets us add a module to what exactly? Yeah, there's a bit of a problem here, isn't there? Because at the moment I've conflated these two kinds of name. The modules have like an internal name, which is what this is supposed to be for. But then when I'm resolving imports, I shouldn't be using this name field. These modules should be there should be a sort of either modules need to have a name, like an array of their exported names, which is not really right, or there should be a sort of a map of exports, which is right. Like, I think probably, let me just stash that for a minute. I think probably what we should do here is that self modules should be empty. Self.exports should be a hash. This name should be nil. And this should have spectest maps to it. And then ultimately, what register should do is just add new entries to this exports hash. So let's see, where do we need to do this to keep track of all of the modules with their private names, because invoke and get can refer to those directly. So we need to be able to just scan through all of the modules that we've defined to be able to retrieve the one with a matching name. And that's okay. Find module. But this should really be exports.fetch. That should really be exports.fetch. Like basically anything that's resolving an import. Like I said, this helper that I should have written, that I haven't written. Yeah, that's also resolving an import. So there should be exports here. Actually, I wonder, do we even need the module instance, or do we just need the exports? Because all of this is redundant. So maybe that makes more sense for us to just cut out the middleman and just do this. And then we don't need this. Does that make more sense? And then when we did register, we would just register the exports of that module rather than the module itself. That seems easier for the time being, rather than having that sort of double. I mean, if nothing else, it just makes this name make more sense. Like, I don't know what to call it otherwise. I suppose it could be exported modules, or it could be registered modules, or... Well, firstly, have I broken anything? Seems okay. Let's do that for now. Yeah, it makes sense. So let's say store module exports separately from modules. And I'll say the previous setup conflated two different namespaces for modules. Their internal ID, e.g. module 1, and their exported name, so let's call this module 1, and their exported name, e.g. spectest. By storing only a module's exports in the exports hash keyed by its exported name, we can separate these two concepts and make it possible to implement the register command. And then I'll just say a nice bonus is that we don't even need to instantiate the spectest module anymore, since it has no real runtime representation outside of the things it exports. Okay, good. So now I think I'm ready to implement register, because now I do know how to register. Of course, it doesn't have what we need. What do we need? Register string name after a module is registered under a string name. So is this defaulting to the most recent one? Let's just let's do it here. Looks like, doesn't it? Let's just look in. So it's not very common, but here, for example, in imports.wast, so do we have any import test? Yeah. So it looks like if the name isn't given, then it's a reference to the last module. Let's just see what it says about test scripts. commands taking an optional module name refer to the most recently defined module if no name is given. Okay. Fine. So register needs string name. What does import module name? I suppose we've called these module name, so I'll do that. So so I can say module name equals parse string. And name is going to be, it's like an ID, right? Yeah. It's like this. I think that's right. Okay, still don't know how to register. I do. And let's say raise register module, well, register name inspect under name module name inspect. Let's just see what that's going to do. Register module 1 under name module 1. Okay. So module equals mod equals find module. How does find module work? You just give it a name. I mean, I can just do this, can't I? I can say exports name equals find module name. Module name. Not the best. Oh, and like find module will already do the right thing here. If it's nil, it will just pick the last one. Right, so it knows about that. Okay. Exports. Oh. Yes, okay. So there's a local variable called exports, and this method is sufficiently massive that that has caused a problem. Okay. So we've actually got two more assertions parsing. So that, well, clearly not quite right yet. Oh, I'm in the wrong. Okay. So let's say implement the register command. Okay. So what's the problem here? Okay, I don't know how tractable this is going to be, but let's... Building tables from imports. Import module name equals module 1, name shared table, kind is table, type equals blah, and tables blah. Okay. Puts exports are exports. Ah, well, I did it wrong, didn't I? Because as previously decided, we set it to the exports of the module, not the module itself. So although that register command it doesn't immediately have any effect because we hit these two asserts before anyone tries to import anything from module 1. So I assume these are out of order intentionally, or maybe not, but either way, these two assertions are not affected by this, but then once we get to module 2, we need the imports to work there. So now that I've done it right, okay, so we're getting closer. Shared table. Okay, so let's look at this again. Let's okay. Building tables from imports, blah 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 blah. I need some new lines in here. Okay. All right, building tables from imports. Exports are spectest, module 1, call 7, call 8, call 9, call 7, call 8, call 9. I somewhat suspect that we're just completely ignoring this inline export. Because that's, yeah, it's just not present. We'll just look at the keys there. Oh. That's not what I want. What have I done wrong there? Forgotten how Ruby works, that's what. Okay, yeah, so spectest, yeah, so it's only exporting the functions. So where does that, well, firstly, let's fix the thing that I got wrong, which is this. But now we have to arrange. So where do we populate the exports, build exports? So functions, globals. This is now going to need tables. Functions, globals, tables, exports. So functions each. Oh, not doing globals at all. I imagine that we're going to need something like this. Tables each do table, case, table. Oh, well, we don't have that. Table exported names each do result name equals table. So we need to arrange for the, so question 1, does the table have exported names? No. So it needs them. And number 2, well, the answer to this is also no. Does the parser put them? Oh, why have I done it there? Stupid. Table. Okay. Number 2, does parse table actually put the exported names on it? Which clearly it doesn't, because they did not exist until a second ago. Fortunately, we've got all of the machinery to do it. We just need to actually stick it on there. I don't think anyone's using the table name, but that's a different annoying problem. In fact, I think I've done all of the bits now, and I would expect it to actually work. Undefined method exported names for table. Oh, this is a runtime table. So yeah, I mean, that's a bit annoying, isn't it? Because the functions here that are returned from build functions, these are just AST nodes. So like I pointed out earlier, when we build tables, we're actually constructing a runtime representation of those tables. And that doesn't include the exported names. So, I mean, it's not the end of the world, but I need to find a way to match them up so that when I'm building the exports, and I mean, globals are going to have the same problem. Because these are also just I think what I'm going to do for now, just for the sake of getting this to work, is add it to the runtime representation. So just copy the exported names on. Yeah, well, I needed to do the thing here. Find a nicer way of generating exports, or well, from inline export abbreviations during module instantiation, squirreling away exported names on the runtime representation is a massive hack. So I'm squirreling away the table's exported names on this kind of runtime representation. I mean, it's not even right. This isn't even right. Because this would cause it to be re-exported if it was imported into another module, and that's not the right behavior. Well, let's see if I can get away with it and doesn't have the right behavior in general, because it will cause things to be re-exported when they're imported. But I'm just going to hack it in for now. I mean, mainly because I'm getting tired and I want to... I'm holding out hope that I can get this working before I give up on this session. So if we've given tables exported names, well, then I think that solves the problem. Apparently not. So under what circumstances can this be? It looks like this can be nil. Okay, well that got quite a long way. And now we've just got some kind of weird other problem. Let me see if I can understand that before I make any commits. So how far are we getting? So we've got 4, 5, 6, 7, 8 assertions are parsing. 1, 2, 3, 4, 5, 6, 7, 8. And then is it this one? This. Am I losing my mind? One, 2, 3, 4. 5, 6, 7, 8. Okay, so it's this one that's the problem. Okay. So what's the problem here? Okay, so the design here is that 8 and 9 are given functions that return 65 and 66. And index 7 in the table is not used. And then now we're supposed to overwrite entries from this module. Oh, no. Okay, well, the reason why this isn't working is because I'm not really storing function references in these tables. I'm just storing indexes. So this table here is actually just storing references to functions at indexes 0 and 1. So here, importing this table, I mean, what actually happens? Expected 67, got 65. Oh, right, because this isn't even invoking stuff inside this module. It's recalling the functions inside. Oh God. Right. Okay. So the entire purpose of this module definition here is to have a side effect on the contents of this table. This table here, this shared table. It's trying to write two new these LMs here, these active element segments are trying to write pointers, references to these two functions into this shared table. But because what I'm actually doing is writing function indexes 0 and 1 into positions 7 and 8, then what you actually get at positions 7 and 8 are references to the functions that return 65 and 66. So that's why this returns 65, not 67. Okay, well, that's a separate problem. Okay. So let's add the AST change, the parser change. That's one thing. Store exported names on table AST nodes. This is a continuation of the hack for implementing inline export abbreviations by remembering them on the AST nodes where they were inlined. It's not pretty. I just realized there's no reason for this to be a struct. Sorry, I just got distracted by that. But otherwise, the change here, well, there's probably two changes. Let's make this data so this is something like use data, make table a data, not a struct. Using struct was a mistake, copied from global above. We never need to mutate or reassign any of tables members. So we just need to so what are the changes here? There's this one. So let's say copy a table, copy the table AST nodes exported names onto its runtime representation. Yeah, I mean this is really wrong, isn't it? This is really wrong, but it's the quickest way to get these names available later so that the module's exports can be populated from inline abbreviations. We need to find a better way of doing this once the lm.wast test is parsing. Okay, and now this is use exported table names when building module exports. For now, these have been smuggled through on the runtime representation of tables. Note that this is not only unpleasant, but also gives us the incorrect behavior in general, since any imported tables will be re-exported under their exported names, which isn't what we want. Please find a better way. Okay, so how close to the end of this are we? I mean, this is quite close to the end. How many more assertions are there after this? What does this one do? This does the same thing again, and not in any interestingly different way. It's just testing it again, but just with different values. And this looks like it's just, this needs table.get and table.set. I think that I'm not going to get this finished in this session because there are several complications here. I mean, this thing about referencing functions from another module is sort of okay, because I could just, as I've mooted a couple of times, I could just put actual function objects in instead of function indexes. But then I think the more serious problem is that I've sort of got lucky here in that these functions that are being exported, or rather these functions that are being, references to which are being written into a table, just return a constant. So as long as we've got the AST node for this function, which is currently what the runtime representation of functions is, then it will be fine, because we'll just evaluate the body and it will return the right value. But looking down here, it's not so simple, because the exported function, it needs to do table.get with a local name of a table within that module, which is going to depend upon current module being set correctly when we evaluate the body of this function. But I don't think that's going to work here. Maybe it's actually not a problem. Like, this is just importing a table and it's writing a different, yeah, maybe it's okay. Maybe it's okay. Maybe I can just try. Let's try it. So here, rather than pushing index, let's push current module dot functions dot slice index. What's the worst that can happen? Let's do that. So that is obviously going to cause some failures, because now call indirect is expecting to find an index. How does call indirect work? I mean, I could have just looked at it here, couldn't I? I just wanted to find a use of it. Call indirect 7. So this is sort of implicitly reading, it's implicitly referencing that table. So call indirect. Yeah, I mean, this doesn't have a table index. So find the right table index. You've popped the index off the stack, so this is a folded instruction. So this 7 will already be on the operand stack. Right, so this is expecting to get a function index here. And then this is expecting to get a function by doing that. And then it's expecting to invoke it. But, okay, call last. Right. No implicit conversion of a function object into an integer. Right. So instead, we can just cut out this entirely. Okay, so that works. Wow, we got all the way to table get. So that all that rubbish worked. Wow. Okay, well, I suppose we're doing that then. Let's just see whether there's anything else that cares about that. Like, what about BR? what is it? Is it BR table? Yeah. Oh, that's okay. No, that's different. That really is just getting, this is just getting labels. Because it's just throwing a tag. That's a whole different situation. So I think maybe it really was only call indirect that was consuming the ref.func result there. Wow. Great. All right, well, I've not only considered it, I've done it. Push use function instances as function references. Not indexes. Using indexes just doesn't work when one module writes function references into a table imported from another module. We need to store the actual function since the index is only valid within the module where that function has been defined. But the function index will sort of work anywhere. As long as the function body doesn't try to do anything that depends upon the current module, e.g. accessing globals. Okay. I'll say I think that call indirect is the only current consumer of these function values from the operand stack. No, we actually read them from a table, so I suppose, yeah. Well, it's more the other way, and from the operand stack, you know, via tables. So it's the only place that needs to be fixed up to support this change. Okay. All right. So table get index equals 0. So how much support do I have in the parser for this? Oh yeah, I added these, didn't I? So yeah, the answer is a little bit. Because the parser knows their arity, their static arity, it knows that they take this argument here, and then the interpreter is just going to need to evaluate, well, in fact, these will already have been evaluated. So let's just, I think I know what table get and table set should do. That'd be it's table instructions, isn't it? Load or store an element in a table respectively. So it doesn't say anything here about. I'm just gonna guess by looking at this. I assume that this is the index I, and then this is the value that's being written into the table. So let's just roll with that. Table set. Oh yeah, the point is we don't have a matching pattern for this yet. Okay. In table.get index. In table.set index. So here this is the table index, right? I think that's right. Right, same thing we do there. So yeah, let's get the arity right of these. So this is like offset, and this is like offset value, and here we're going to return table elements slice offset, and here we're going to do table elements offset equals value. And then what is table set supposed to... Does it need to return anything? Does it need to leave anything on the stack? Is it like local set that doesn't because there's a T? Let's see. Table get, push the value out of the stack. Nope, it seems to just consume it off the stack. Unhandled exception. Okay, why has that happened? Expected ref null, actual. Interesting. So what does ref null do? Oh, of course, table get needs to actually push this onto the stack. No one cares what the return value is. We've got to push that value onto the stack. Hey! It all passes. Wow. Wow. Okay. Well, I'm glad I hung in there for a sec. Wow. Okay. Implement the table.get and table.set instructions. And I believe that we also need to move this, because LM is finally parsing. Oh, wow. Well, I'm glad I hung in there for that last bit, because I was ready to give up at that point. But it was only when I... See, this shows the power of rubber ducking stuff, or at least having to justify your decisions, because I think if I'd been just working on this by myself in private, I think I would have given up at that point, because I'd told a story to myself about the fact that this wasn't going to work because something about... Yeah, I'd constructed a belief in my head that said, these exported functions here that get written, or these functions that get written into a shared table, only work when they're called because they don't need any of the context of the module that they're defined in. Because at the moment, functions don't know anything about which module they're in. I need some mechanism so that when a function is invoked, we sort of temporarily set current module to be the correct one for that function, so that if it wants to read any globals or whatever, it knows what module to look in for those globals, and I haven't done any of that stuff. So I had somehow told myself that that was going to be a problem here, but once I started trying to justify that decision and I actually looked at these functions, I was like, oh no, it's not a problem. It's not even the same kind of thing going on here. This is just about, I don't know, messing around with these externrefs here. And it sort of all seems to be fine. I mean, I'm a little bit concerned that these ref.externs might not have held on to the... Like, they might just be empty objects. Yes, unfortunately they are. Let's just look at that really quickly. Ref.extern. Where does that live if not in reference instructions? That is baffling. Ref null, ref is null, ref.func. Hold on, am I just not understanding this properly? Okay, so this is... So what does this mean? A host reference. So this isn't part of WebAssembly syntax. This is part of the interpreter's special business. So what's this supposed to do? Ref.extern 42. Yeah, I mean, I don't actually understand what this is supposed to... So this makes a table, and when we get stuff from it, we're supposed to get null, and then we can write in right, so at the moment it just pushes some kind of special value onto the stack, a symbol. It doesn't actually remember the original value though. So let's just do this for fun. Oops, that's not right. So this is actually supposed to be a natural number. So instead of this, let's say value equals parse integer 32-bit. So that'll let us put a 32-bit integer into this. And then let's say a special little hash like this. Okay, it still works. It still works. Let's say store actual host reference value in ref.extern result. And let's just say previously we were representing all ref.extern values with a generic symbol, but now at least we're remembering the original value, which makes the assertion success a bit more convincing. Okay, so this is like another weird value that we can get on the stack. But yeah, that's a little bit more convincing, I think. Okay, I think that's enough for me for now. And I'm happy that I've got another test file working. I mean, that one felt very hard won. There were lots of individual things I needed to fix to make that work. But fix them all I did. So a bit of an uphill struggle. Not too much parsing, actually. Obviously, I live in fear of having to touch that parser. And I did have to touch it a little bit, but not too much. I feel like I spent more time in the interpreter than in the parser this time. So that's like a good situation. I support the register command. I've done that. don't think I've accidentally done anything else there, which would be nice, but I don't think so. Okay. Are we done? Oh no, we're still going. Yes. God, it's such a relief when it goes green. There's always just that moment of terror where I'm like, oh, am I going to be here for another half an hour just getting that, getting something else to work? Okay. All right. So, I think that was okay. I didn't mind that. Yeah, a bit fiddly. Lots of things to semi-understand and get working, and I did have to do quite a lot more hacking to get it there, so I don't feel great about that, but I've got the test parsing, so next time I can go back and try and unpick some of that hacking, try and think about a better way of doing that whole module assembly process. And I mean, it all ties back into trying to contain the horror of how I've implemented the inline exports and imports. I think I'm happy to leave the AST as it is for now, but I just need those translation functions that live in the interpreter that deal with module instantiation. I just need to make sure that they can cope with it without, at the moment, the problem is those exported names are leaking out into the runtime representation, and that's not good. So I think even if I have to do some unpleasant gymnastics in module instantiation to do with like perhaps generating exports as I go rather than trying to consolidate them all at the end or something like that, I can imagine that working. But yeah, otherwise I'm pretty chuffed with that. I didn't know whether I was going to get to that point, but I got something working, so that's actually very nice. So I think that's it. I'm going to say bye. If you're watching this, if indeed anyone is watching this, then thank you. I'm grateful for you watching it. Yeah, just keep it on going with this. I appreciate your continued or occasional or one-off interest. So thanks for watching this. I will see you next time. Bye-bye.